I'm going to look at a couple of problems with more than two independent events. So the same formula applies. If you have independent events, then you can just multiply the individual probabilities together to get your total probability. So here, my probability of spinning on the red sector, of rolling a number greater than 3, or sorry, greater than 4, and tossing a tail would be all those individual probabilities multiplied together. So then it's just a matter of calculating those. So the probability of spinning a red would be 1 out of 4. The probability of getting a number greater than 4, well, that would be a 5 or a 6 would be my favorable outcomes. And I have 6 outcomes in total. And the probability of tossing a tail is just 1 out of 2. So I can work that out. I can reduce some of these fractions first. 2 out of 6 I know is just 1 out of 3. So now I can multiply 1 times 1 times 1 is 1. And 4 times 3 is 12. Times 2 is 24. So I have a 1 out of 24 chance, 1 out of 24 probability of spinning a red, rolling a number greater than 4, and tossing a tail. One question that comes up a lot here is what is the probability of tossing 4 tails in a row? So again, this is the theoretical probability. This is not something that you try to do. And we can calculate that because we know that the probability of tossing a tail is 1/2 each time. So if I want to calculate the probability, I would just multiply those all together. So my probability of tossing 4 tails in a row would be 1 out of 2 times 2 is 4, times 2 is 8, times 2 is 16. 1 out of 16 would be my probability of tossing 4 tails. 4 tails in a row. So I hope that helps. Just to take your individual probabilities and multiply them together. As long as they're independent events, you're going to be okay with all of these types of problems. Good luck, and thanks for listening.